France, 1944. A Jeep is down at the edge of a military road. The failed assembly comes off. A replacement comes out of a crate. The vehicle may have been built by Willys-Overland. The replacement may have come from Ford. For the soldier holding the wrench, that distinction is supposed to mean nothing. The part fits. That single fact explains more about the Jeep's wartime importance than its horsepower, its four-wheel drive, or its famous shape. Two competing American companies built versions of the same military vehicle, and the Army required those vehicles to function as one standardized machine. Ford commonly marked many of its Jeep components with the company's small script F, while Willys built parts did not use that Ford mark. On a stripped standardized vehicle, those markings could reveal pieces from different manufacturers designed to occupy the same place and perform the same job. Now shift the scene to North Africa in early 1943. In the weeks after the fighting around Kasserine Pass, Axis forces had access to abandoned and captured American equipment. A recovered Jeep would have been a natural object for a German workshop crew to inspect. No surviving German report records a mechanic discovering the Ford and Willys mixture or reacting to it. Any such workshop scene has to remain a reconstruction. We do not need to invent a speech for the men around the bench. The machine itself reveals the important contrast. For a German engineer, interchangeable parts from separate American factories pointed to a different idea of what a military vehicle was supposed to be. The Jeep itself was not especially sophisticated. Its greater advantage was that the system behind it had already decided, years before the vehicle reached the battlefield, that repair should require as little individual fitting as possible. The broken part came off, the replacement went on, and the replacement was supposed to fit. That sounds obvious now. In 1943, across the world's armies, it was anything but trivial. The Jeep began in a hurry. In June 1940, with France collapsing and the United States watching the war spread across Europe, the U.S. Army asked industry for a small four-wheel drive reconnaissance vehicle. The requirements were severe. The vehicle had to be light, compact, able to carry men and equipment over rough ground, and a running prototype had to appear in only 49 days. Most companies did not even try. American Bantam Car Company did. Bantam was a small Pennsylvania firm with little money and little margin for failure. It brought in freelance engineer Karl Probst, who helped lay out the first design under extraordinary time pressure. Bantam delivered its prototype to the Army on the final day of the deadline. That should have been the beginning of Bantam's triumph. Instead, it became the beginning of something much larger than Bantam. The Army wanted competition, production capacity, and a vehicle it could obtain in enormous numbers. Willys-Overland and Ford were brought into the program. Willys refined the design and supplied its more powerful Go Devil engine. The Army standardized the vehicle around the Willys version, then required Ford to build the standardized vehicle as well. Not merely a similar Ford light car, a Ford-built version that would function as the same military object. That decision is where the Jeep becomes more interesting than its silhouette. A Jeep was simple, roughly 2,400 pounds, an 80-inch wheelbase, flat body panels, a folding windshield, no armor, no standard weapon built into the vehicle itself. Its four-cylinder engine was practical rather than exotic. A skilled European designer could have produced a more refined light car. And interchangeability did not mean that American factories simply accepted careless workmanship. The important distinction was control. A part could be produced within a tolerance wide enough for economical mass manufacture. But that tolerance had to be defined, measured, and enforced, so the part still performed its function in any standardized vehicle. The precision moved away from the individual fitter and into the production system. That trade-off shaped the Jeep. Features that added complexity had to justify what they cost in weight, production time, training, and maintenance. A flat panel was easier to make and repair than elaborate bodywork. A common assembly was more valuable than a unique assembly that performed slightly better but demanded its own stock of spares. Refinement was not the problem the U.S. Army was trying to solve. The problem was distance. An American vehicle might be built in Ohio or Michigan, shipped across an ocean, unloaded at a foreign port, driven hundreds of miles, then broken by mud, dust, collision, overloading, neglected maintenance, enemy fire, or simple hard use. The person trying to return it to service might not be a master mechanic. He might be a 19-year-old soldier who had been driving a truck back home less than 2 years earlier. So the vehicle had to belong to a repair system designed for that man. That system was much older than the Jeep. During the 19th century, American armories and manufacturers pushed increasingly toward interchangeable manufacture. Instead of relying on a craftsman to hand-fit every individual component, more of the precision was transferred into gauges, jigs, machine tools, inspection standards, and repeatable processes. The goal was simple to say and difficult to achieve. Make one part close enough to specification that it can replace another part without being individually matched to the machine. By the middle of the 19th century, European observers were studying that American approach. By the 20th century, it had become deeply embedded in American mass production. That industrial habit mattered when the Army told one automobile company to manufacture another company's standardized military vehicle. The instruction only works if drawings, gauges, inspections, tooling, contracts, and factory discipline all point toward the same result. A Ford part must not merely resemble a Willys part. It must occupy the same space and perform the same job. By war's end, roughly 647,000 standardized Jeeps had been built, most by Willys and Ford. Their battlefield value came partly from the number of vehicles. But quantity alone does not explain what happened after one of them failed. Imagine a Jeep in France in 1944 with a damaged water pump. The driver does not need to know which factory produced the vehicle. He does not need to search for a Willys-only repair team or a Ford-only warehouse. If the supply system is working, he needs the correct replacement assembly, a set of tools, and enough time to install it. If the new part came from the other manufacturer's production line, that distinction is supposed to be irrelevant. And if no new part is available, another damaged Jeep can become a donor. A vehicle hit by shell fire may still have a usable distributor, wheel hub, generator, or axle component. The dead vehicle becomes a small parts warehouse because the Army has reduced the number of compatibility questions the mechanic has to ask. This is a different philosophy of repair. In a craft-centered system, repair often means diagnosis followed by skilled fitting. The mechanic measures. He files, he shims, he adjusts. He knows how to make an imperfect replacement work inside a specific machine. That is not primitive, it is a demanding form of competence. Germany had an extraordinary tradition of that kind of engineering and workmanship. But armies create a brutal test for any system that depends heavily on scarce skill. A trained craftsman takes years to develop. A war can consume him in days. A workshop needs tools, benches, power, gauges, specialist knowledge, and time. A front moving hundreds of miles away from the factory may have almost none of those things when a vehicle fails. The American approach tried to spend more precision before the breakdown happened. It also tried to separate levels of maintenance. Field personnel could replace assemblies quickly, while more difficult rebuilding and machining could be pushed farther to the rear, where specialists, benches, and proper tools were available. That mattered because the fastest repair at the front was often not the most elegant repair. It was the repair that returned the vehicle to service before the column moved again. Put the difficult work into the factory. Put the tolerance into the gauge. Put the compatibility into the contract. Then send the field mechanic a part that is already supposed to fit. This is where the contrast with German motor transport becomes sharp. Before the war, the German army already knew it had a standardization problem. German vehicle production was spread across many respected manufacturers, each with its own models, components, engineering traditions, and supply requirements. The Wehrmacht tried to reduce that variety through what became known as the Shell Plan, an effort begun before the war to cut the number of approved vehicle types. The diagnosis was correct. The battlefield made the cure harder. As German forces expanded across Europe, their transport inventory absorbed enormous numbers of vehicles from conquered countries. French trucks, Czech vehicles, captured Soviet machines, civilian models, imported designs, and German types all entered a system already struggling with variety. Every additional model could mean another engine family, another electrical system, another clutch, another wheel bearing, another thread standard, another manual, another shelf of parts. A truck that looked useful on the day it was captured could become a liability months later if no reliable stream of compatible spares followed it. The more types an army operated, the more warehouse space, transport capacity, mechanics knowledge, and paperwork had to be divided among machines that could not help repair one another. The Wehrmacht also remained heavily dependent on horses because it never possessed enough standardized motor transport to replace animal traction across the entire army. This was not because German engineers had failed to understand the value of standardization. They understood it. The difficulty was industrial and institutional. Standardization is not a switch an army flips after mobilization. It reaches backward into design offices, machine tools, gauges, supplier contracts, manufacturing tolerances, inspection practice, and the willingness of different firms to surrender some of their individual engineering preferences to a shared standard. Germany even built a vehicle whose name announced the ambition. the leichter Einheitspkw, the light standardized passenger car. It was produced by several manufacturers, but its complexity worked against the idea it was meant to embody. Different builders used different engines. Early versions included sophisticated features such as four-wheel steering. The vehicle was capable, but it was heavy, expensive, and difficult to produce and maintain in the numbers Germany needed. Eventually, the simpler Volkswagen-based Kübelwagen became the more practical light utility vehicle. The Kübelwagen was not a bad design. Its lightweight, air-cooled engine and simple layout gave it real advantages. But the scale of production was very different. The source material places Kübelwagen production at roughly 50,000 vehicles, compared with well over 500,000 standardized American Jeeps. That difference mattered because a repair system becomes more powerful when the same machine appears everywhere. A common vehicle simplifies training. It simplifies manuals. It simplifies stocking. It increases the chance that a damaged vehicle nearby contains the part you need. It allows a driver transferred between units to recognize the controls, the faults, and the repair logic immediately. And it allows the supply chain to behave as though thousands of separate vehicles are one enormous repeated object. That is what a German workshop crew inspecting a captured Jeep could have seen on a bench. Not superior metallurgy, not a secret engine, not a hidden weapon. A production agreement made visible in steel. Two corporations that had competed for the same contract had been forced to manufacture compatible versions of the same machine. For an army, that agreement could be more valuable than a beautifully optimized component. Captured Jeeps made the point in another way. German units used captured Allied vehicles whenever they could keep them running. A captured Jeep was useful because the Jeep was useful. It was compact, mobile, familiar across Allied formations, and available in large numbers. But capture exposed the limit of the object by itself. The Germans could seize the vehicle. They could seize the fuel in its tank. They might even seize a few spare parts. What they could not seize permanently was the industrial river behind it. The crates coming off ships. The depots stacked with standardized assemblies. The manuals written for one common vehicle family. The factories thousands of miles away making replacement parts to the same dimensional expectations. A captured Jeep separated from that river slowly became just another foreign vehicle in the German inventory. In December 1944, during the Ardennes Offensive, Otto Skorzeny's Operation Greif used German troops in American uniforms and captured American vehicles, including Jeeps, in an attempt to create confusion behind Allied lines. The deception worked well enough to create nervous checkpoints and identification tests, but it also demonstrated the difference between possession and support. A vehicle can change hands in minutes. A production system cannot. And this is the point where battlefield arithmetic changes. A vehicle's value is not only whether it can move today. It is how many days it can remain available over months of hard service, how quickly a damaged example can return to duty, and how much transportation capacity must be spent keeping it alive. Standardization lowers the number of different answers the supply system must carry forward. In a continental war, that can matter as much as horsepower. That is why the Jeep's most important wartime feature is easy to miss when the vehicle sits in a museum. Museum displays encourage people to study the object. The wheels, the engine, the body, the dashboard, the folded windshield. But the deeper design extends beyond the frame. It includes the gauge on a factory floor, the inspector rejecting a part that falls outside tolerance, the drawing shared across companies, the wooden crate in a depot, the mechanic who does not need to become a machinist before he can return a vehicle to service. The Army did not merely buy Jeeps, it bought repeated compatibility. And there was a cost to that logic. American Bantam had answered the original challenge when almost everyone else walked away. Karl Probst and Bantam helped create the vehicle that became the basis of the wartime Jeep program. Yet the mass production system did not reward origin in the way a romantic inventor story would. The Army needed capacity, commonality, and enormous output. Bantam built early vehicles, then spent much of the war producing trailers while Willys and Ford built the standardized Jeep in vast numbers. The same industrial logic that made one part replaceable by another also made one producer less important than the standard itself. That is an uncomfortable part of the story, but it reveals what the system valued, not the uniqueness of the individual object, not the prestige of the craftsman who could rescue a badly matched component, not even the company name stamped into the metal. The priority was to make the next part fit. So return to the roadside in France. The mechanic tightens the last fastener. The engine turns. The Jeep goes back into the column. He does not need to know which corporation cast the replacement part. He only needs the promise made years earlier by drawings, gauges, inspectors, factories, depots, and contracts. The part will fit.